Alright, welcome back. This is the second part of section 1.3. I worked these three problems in the last video. We're talking about quadratic equations and solving quadratic equations using various methods. So I'm going to just continue on. I'm on page 117. And I'm going to do problem 37. So this one says, solve each equation by completing, no, I don't need to, I need to do 33, sorry about that, 33. Solve each equation using the square root method. So this one's pretty simple. X minus 1 squared equals 4. So I can probably, this is simple enough where you can probably figure it out. If the square of something is 4, then the value of this has to be 2, right? Or negative 2. Because 2 squared is 4. So what would make this 2? 3 would, wouldn't it? 3 minus 1 is 2, 2 squared is 4. So I know 3 is an answer. Right? Or negative 1 is an answer. Because negative 1 minus 1 is negative 2, and negative 2 squared is 4, so x is negative 2. So some of these, when they're this simple, you can probably just reason it out. Right? But the method, you don't see it, and some of them will be more complex, is you basically just take the square root of both sides in this situation, because that's a perfect square. Well, even if it isn't, it still works. And that's a perfect square, obviously. So when you take the square root of x minus 1 squared, the square just cancels, and you get x minus 1 equals what? 2, but you also get negative 2, right? So there's two answers here. There's two equations. You got x minus 1 is 2, but also x minus 1 is negative 2, right? Alright, so when I add 1 to both sides here, I get my 3, which I was talking about, so x equals 3 for this one. And over here, when I add 1, I get what? Negative 1, which is, oh, what did I say? I said this is negative 1. Okay, I've been doing this too long. Sorry, negative 1 minus 1 is 2, negative 2, and negative 2 squared is positive 4. Alright, so x equals negative 1. I need to slow down a little bit. Alright, so that's 33, and that's how you do those type of problems. Alright, 37 is solving by completing the square. So we'll do 37, x squared plus 4x equals 21. Let's see if I can remember this idea of completing the square. You've got this value of x. Let's say we'll call this a geometric representation. So if that's x, and that's x. In other words, if the length of this little square is x, then the area of the square is x squared. So you can think of this square right here as representing this term. Alright, 4x. That means what we want is a value of 4. So what I'm going to do is I'm going to cut that in half. Or I'm going to get half of it here. So let's say this is, let's say the value of this is 2, right? And this is still x, isn't it? So then the area of this right here is what? It's 2x, isn't it? If I do the same thing over here, where this is 2 and this is x, then the area of this rectangle here is 2x. So now these two rectangles together make 4x, which is represented by that. And if you add all these areas up, the idea here is it has to come out to be 21. So then what is x, right? Such that when you find the area of these three pieces and add the areas, you get 21. Well, there's this trick which is called completing the square. So what we want to do is fill this in right here to make this a whole new square, right? So what would the area of this be, this part? Well, this is 2, right, because that's 2. And this is 2 because that's 2. So the area of this is 4. So if the area of these 3 pieces here is 21, then the area of this whole thing is 4 more than that. So it's what, 25, right? So, and all I did was I added 4 to this. So I can say, well, x squared plus 4x plus 4 more is 21 plus 4 more. Okay, so what is the point of that? Well, notice that I've created this perfect square here, and it has a side length of x plus 2, x plus 2. So I know that this factors down to x plus 2 squared. Remember, x squared plus 4x plus 4 represents the area of this whole square, right? And its length on each side is x plus 2. And this has to equal 25, right? Because these 3 pieces were 21, and I just added 4 more to it, so that's 25. Well, now I've got it to where I can just take the square root of both sides. Right? So if I take the square root of this side, I get x plus 2. And if I take the square root of this side, I get 5 and negative 5, so plus or minus 5. So now I can find the 2 values that'll work here. So if I let's just make it 2 equations. X plus 2 is 5, and x plus 2 is negative 5. So x equals, what, 3 here, and x equals negative 7 here. So those are the 2 equations. The 2 solutions to this equation. Alright, so what we'd like is, well, that's all fine and dandy, right? The area of this x squared. What's the method? Okay. The method is basically, let's start over. So you have your quadratic term, you have your linear term. And you want nothing here, you're just going to put a blank, right? You want there to be a blank here. And then your number here. And you're going to put a blank here, because we're going to add something here and add something here. And the number we add here is going to create that situation where this quadratic is going to be a perfect square trinomial, right? So it'll factor down to something times itself, like this did right here. It factored down to x plus 2, x plus 2. A trick to finding it is just to look at the linear term, cut it in half. So it's 4 right now, cut it in half, it's 2, and square it, which is 4 again. Alright, so if that were 3, then I cut it in half, that'd be 3 halves. And when I squared it, I would get 9/4, and that's what I'd have to put here. But in this case, it's half of that's 2, square it, you get 4, so I put 4 here, and then now you have x squared plus 4x plus 4 is 25, and that's perfect square trinomial, so it will factor to x plus 2 squared. You could do x plus 2 times x plus 2, multiply it out, and you will get this, right? Just if you want to convince yourself. And then from there on out, you just follow what I did over here. So that's the method of completing the square. So I'll do another one without the geometry part. I'll just follow the steps. Let's look at some of these are really ugly. Let's do one that's not too complicated. So I'll do 38. And it's 38, so remember you're going to leave a blank here, leave a blank here. Alright, so what number goes here? How do you find it? Well, remember you cut that in half, so that's negative 3. Square it, positive 9. So 9 goes here, 9 goes here. Alright, so we've created a perfect square trinomial. This will factor down to x minus 3 squared. So square root of that's 3. Minus because that's minus. And then 13 and 9 is 22. So now you take the square root of both sides. Take the square root of this side, you get x minus 3. And the square root of 22 is plus or minus the square root of 22. right? And then you can add 3 to both sides, so x equals 3 plus or minus the square root of 22. And what number was that? 38. Yeah, that's it. So there's 2 answers there, right? 3 plus square root of 22 and 3 minus square root of 22. Just keep that in mind. Okay. The next section says use the quadratic formula. So what is the quadratic formula? That's negative b plus or minus the square root of b squared minus 4ac all divided by 2a, where you have ax squared plus bx plus c equals 0, right? So the coefficient of your quadratic term is your a, which goes here and here. The coefficient of your linear term is b, which goes here and here. And this is your constant, which only goes here. So you just find those, plug it in, and you can derive this formula straight from the completing the square method, which I won't bore you with, but it is in your book if you're interested in that. Alright, so let's look at 43. We have x squared minus 4x plus 2 equals 0. So we need, what's a, b, and c? Well, a is right there, it's 1. There's nothing there, so it's 1. b is this term, negative 4, and c is the constant, which is 2. Alright, so now all we do is we plug those into this formula. So x equals negative b, the opposite of b. b is negative 4, so the opposite of b is positive 4. Plus or minus the square root of b squared, so that's negative 4 squared minus 4 times a is 1, times c is 2, all divided by 2 times a, which is 1. Alright, 4 plus or minus the square root of 16 minus 4 times 1 times 2 is what, 8 over 2. Alright, this part right here, by the way, this is called the determinant. Determinant, how do you spell that with an A? No, sorry, not the determinant. That's in matrix algebra. Discriminant. It's a discriminant. Alright. If the value of that comes out to be negative, we have a problem, right? Because you can't take square root of a negative, you end up getting an imaginary number. If it comes out to equal 0, well then you end up, your solution just comes out to be negative b over 2a if the discriminant is 0. In this case, the discriminant looks like it is some positive value of 8. So 4 plus or minus the square root of 8 over 2. Alright, so this is 43. So now we just want to make this prettier, right? Actually, that's a fine answer. However, I'm pretty sure in math lab they're going to want that in simplest radical form. And there's a 4 in there and that 8 right there that you can pull out of there. So x equals 4 plus or minus the square root of 8, right? Well, 8 can be broken up into 4 times 2, can't it? Well, why would I do that? Well, I'm looking for numbers like 4 that have a square root. 9, 16, 25, 36, 49, all those, right? Those are perfect squares. That comes out as a 2. So now we have 4 plus or minus 2 square root of 2 over 2. Well, now stuff cancels here, right? Because this 2 can cancel with both of these. Remember, over here, I couldn't cancel the 2 with that 4. Because there's 2 terms up here. And the 2 would have to cancel with both of these terms. So I can't cancel it here if I can't cancel it here, right? But now, I can. So This goes into that, so that's just 2 plus or minus square root of 2. Alright, so that's it. That's the solution. Those are the solutions. 2 plus square root of 2 and 2 minus square root of 2. Now, what are those approximately? So, let's look and see. 2 plus square root of 2 is about 3.41. And minus square root of 2, 2 minus square root of 2 is 0.59 about. Alright, so that's the approximate solution. So if you were to graph this, what you're asked to do, graph it and see if the solutions match. Alright, I'll leave that for you to do. So that was 43. Let's look at, guess I'll do 57. So 3/4 x squared minus 1/4 x squared minus 1/2 equals 0. Alright. So technically A is 3/4, B is negative 1/4, C is 1/2. Ugh, who wants to plug a bunch of fractions into this formula, right? We don't want to have this full of fractions. So since it equals 0, I can go ahead and multiply through. I can just multiply everything by 4 and get rid of those stupid denominators, and this one as well has to be multiplied by 4, right? And then you'll get a new equation with no denominators that has the same exact solutions as this one does. So now I get 3x squared minus, that's supposed to be an x, I think, minus x. Now this is 4 over 2, so that's minus 2, and 4 times 0 is 0. Okay, so that's better, right? So now my A is 3, my B is negative 1, and my C is negative 2. So let's plug and chug. So x equals, using the formula up here, so you can look up here to see what I'm doing. So negative b, that's going to be positive 1, plus or minus the square root of b squared. Well, if I square that, I get 1, minus 4 times a, which is 3, times c, which is negative 2, all over 2 times a, which is 6. Alright, so that's 1 plus or minus the square root of 1 plus, there's a negative and a negative, so I'm going to end up with a plus 1224 all over 6. So x equals 1 plus or minus the square root of 25 over 6. Alright, well we can keep going because square root of 25 is just 5, right? So this is 1 plus or minus 5 over 6. So let's figure out what those are. Well, 1 plus 5 over 6 is 6 over 6, which is 1. That's one answer. And 1 minus 5 over 6 is negative 4 over 6, so negative 2/3 is the other answer. And that was what number again? 57. So that's it. You can check those on your calculator and see that they are indeed correct. Alright. The next section says, use the discriminant to determine whether each quadratic equation has 2 unequal real solutions. A repeated real solution or no real solution without solving the equation. So for 67, we have 2x squared minus 6x plus 7 equals 0. The discriminant, remember, is just this part, b squared minus 4ac. That's the discriminant. So what we're looking for is, we just want to know b squared minus 4ac. What does the discriminant tell us about the solutions? We don't really need to find out what exactly they are. Just use the discriminant to find out some of the characteristics of the solution, right? So b squared would be what? Negative 6 squared, because that's b, minus 4 times a, which is 2, times c, which is 7. So that's 36 minus, what? 8 times 7 is 56, isn't it? So this is, looks like negative 20. Okay. So the discriminant is negative 20. Remember, the discriminant lives underneath the square root. So if you have a negative under a square root, that means you've got two imaginary or complex roots, right? They're not real. And the directions say use the discriminant to determine whether each quadratic equation has two unequal real solutions, a repeated real solution, or no real solution. So we can just say no real solutions. The reason being is the discriminant is negative. So we have b squared minus 4ac. If it's less than 0, no real solutions, right? If b squared minus 4ac equals 0, then you're going to have one real solution. And it will be negative b over 2a. That'll be your solution, right? That's how you would find it. Look at the equation and you'll see why. All right, and then if b squared minus 4ac is greater than 0, well, then you have two real solutions. Now, if the number, let's see, and this is what we call a repeated solution. They called it a repeated solution right here. So it's a double root, I guess we could say. Right, in this situation right here. Technically, you always have two solutions, I guess, but sometimes it's the same number twice. Alright, so that's how you work out those type of problems. You just use b squared minus 4ac and check one of these. It's got to be one of these three rules, and that'll tell you something about the roots or the solutions. And I'm going to stop there for now. I might do a little more later. Some of the word problems we need to work. That's it. Thanks so much for watching. Good job hanging in there. Bye.